Okay, I have started the recording, guys. Let me share my screen as well. Just give me 2 more days because we need to complete three more data types. So we have to complete the character data type. I will show you now. So yesterday we were discussing about we got some understanding about the data types. Like we know what is byte, we got to know what is int, what is long, and what is short. We also got to know how to perform the declaration, initialization, and we also got to know the performance of the plus operator, the importance of the plus operator, the behavior of the plus operator between two operands. We have got to understand so many things. So we have got some confidence. I also want you to understand the new data type which we are going to see today, which is what the char data type. Okay. Now focus here from the char data type. For example, if you are giving an interview, if they want to check your caliber on the primitive data types, they will touch this topic, especially the char data type. Okay, it looks very simple. It looks very simple, but there are a lot of tricky questions. Char data, when I say char data type, it is a data type which is going to store a character. Okay? I can give this conclusion, but if I give this conclusion, you cannot answer the tricky interview questions. There is a big logic behind this. A huge amount of logic is there behind this. Trust me, you will not get this logic anywhere. Okay, people who are taking Java classes, they don't teach you all these things, the internal things. So that's why people fail in the interview rooms, right? Focus here. Whatever it is, if you are not understanding, just unmute and speak to me so that I will tell you in the different way. Let us see. Let us discuss about the char data type. Okay. The first question is, it is an unsigned data type. Give me a minute. I will turn off this fan. 1 minute. Okay. The char data type is also called as unsigned data type. Unsigned data type. Okay, so the data types that we have discussed so far. What are the data types that we have discussed so far? We have discussed about byte, we have discussed about short, int, and long. Right? What is a common thing in these data types? So all the four data types are what? The signed data type. When I say signed data type, they represent both negative numbers as well as the positive numbers. But when it comes to char data type, it is an unsigned data type. Unsigned means what? It is going to represent only the positive numbers. Okay? Positive numbers. Let us talk about the size also. When I say size, the size of the char data type is 2 bytes. Okay, the size of the char data type is what? Is 2 bytes. Again, 2 bytes is collection of or group of 16 bits. Okay, second point is also very clear. And the third point is the range is from 0 to 65,535. This is the range, right? But there is a contradiction. So I am saying I am giving you the range in the form of numerical values. But don't you think that the char data type is going to store all the English alphabets? But why the range is given in the numbers? That should be the first question. Okay? And the second question is, and look at the contradiction. The char data type is used to store the letters. Store the letters or symbols in the form of Unicode. I will also tell you what is a Unicode. Okay, stay focused. So these are the four major points that I can give. So we will talk about the default values later. First of all, let us understand what is the unsigned. We know what is signed, but what is unsigned? When I say unsigned, any number, if any whole number, if that is getting represented without negative signature, okay, it has to start from 0 and it has to end on a particular positive number. It has to start from 0, always start from 0, and it has to end on a particular positive number. That is the case. And if you want to define such data type, you say it as what? Unsigned data type, right? So let us recreate the size. Let us try to register the bits. How many registries will be there? There will be 16-bit registry, yes or no? Right? So you have what? You have the combination of 8 bits. Okay, I mean group of 8 bits. 1, 2, 3, 4, again 5, 6, 7, 8. Right? So this is 8-bit registry, and another 8-bit registry is going to make what? 16-bit registry. Okay. Combination of two 8-bit registry, right? If it is unsigned, okay, if it unsigned, always remember when you are dealing with the unsigned data type, you will not think about this MSB. MSB concept will not be applied for the unsigned data type. Okay. So the minimum number is going to be what? The minimum number has to be 0. Okay. If I want to represent the minimum number, if I want to represent the maximum number by using the bit manipulations, what I'm supposed to do, it is very clear that the minimum number is going to be 0. Right? I can say all the bits will be placed with the number 0. Okay. You get what? You get minimum number. You get minimum number. If you want to find the maximum number, you place all the bits, all the individual bits with the value 1. Okay, and you know how to convert this big binary number into the equivalent decimal number. What you do? You just increase the significant of 2's power, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 7, and like that you get 2 to the power of 15. If you perform this calculation, if you convert this calculation, if you evaluate this, you will get such a big number. What is a big number? You get the maximum number. What is the maximum number? In this case, you get 65,535. Okay, this is how you can calculate the range with bit manipulations. What is the other way? So there is a formula for this as well. What is the formula to find the maximum number? To find the maximum range? What is the formula? Okay, 2 into n to the power of n minus 1. Okay, so this formula will also give you what? This formula will also give you the maximum range, which is 65,535. You can calculate the range in either ways, right? And the second thing is, okay, we need to understand. So when it is signed, you don't care about MSB. First understand that you don't care about MSB. Okay? And also to find the range, you can either go with the bit manipulations or you can use this formula. You can use this formula to calculate the range, where this 2 is what? 2 is representing number of bits. Okay, just substitute the number of bits. I mean 2 to the power of 16. 16 minus 1. You will get this big number. You will get this number. Okay, now let us understand. Sir, you are saying that the range is from 0. Okay, the range is in the form of the numerical representation. Okay, and also you are putting a contradiction, like this character is going to store a value of what type? Of character type. Let us say that the example is char a equal to a. Okay, this a is representing the letter, but the range is represented in the form of numerical value. Why it is like that? To understand this, I will introduce a topic called what? Unicode. Let us understand what is Unicode first. Later we will come to this question. Okay, so Unicode. So this is very, very important topic, Unicode. You will come across this Unicode when you are developing an application which requires to do with a lot of string manipulations. When I say that, what I really mean is when you want to deal with the different languages. For example, If your project needs to communicate with the end user, if your web application wants to communicate with the end user in different languages. So in Telugu namaskaram, okay, you should give the welcome message in the Telugu, not in English but in Telugu, in the Telugu language. So this is in English, but the meaning is in Telugu. But in the Telugu language, you want to give the information to the end user. Or if you want to give the information like vanakkam in the Tamil language, vanakkam means namaskaram in the Tamil language. Or if you want to give the information in the Hindi language, okay, Unicodes are used here to do this conversion, to transmit the data. For example, if you have two machines, okay, if there are two machines, and this machine has designed a web application, okay, you can open a web application on the machine one. Let us say that this is the machine one, and let us say this is the machine two. You can, if you open any web application, so the machine one says you can open any web application in my machine, but please ensure that the web application is what, the English web application. And machine 2 says you can also open any application, but the web application that you're opening has to be in the Tamil language or Telugu language, the regional language application. If you want to if these two application needs to communicate together, okay, the text communication, okay, the translation should be there. That translation will happen only with the help of Unicodes. Okay, practically, if you want to understand this, so back in 1940 and in 1945, okay, so there was a huge amount of competition. I am saying what, 1945. There was a huge amount of competition between two countries in the world. If you know, one of the countries is USA. Okay, the second country, the other country, the competitor is what, USSR, Soviet Union. Okay, so there was a Cold War between these two countries. When I say Cold War is nothing but what? So they are very competitive. These two countries are very much competitive in nature, and they have a huge amount of ideological differences. Okay, and there was a huge amount of space race. It was like if USSR has launched a rocket, right? So they were very good in space technology during this period from 1945. Russia was the first country to send a rocket to the space. So they are very good in the space technology. No major failures. Okay, and also they have sent a dog to the space. Okay, what US did? US did what? So in order to take revenge for that, US sent humans to the space. Okay, if US is developing one technology, okay, Russians are going to add some additional features to that technology. So this technology would be far more advanced. Okay, there would be a race between these two countries. Nuclear race was there, nuclear arms race was there. Okay, and also what, they fought for what, they fought for the power. They want to dominate. Okay, USA want to dominate in the European region. USSR also want to dominate in the European region. How the domination can happen? The technology will dominate. The technology that they are having, that they are possessing, that is going to dominate, right? But what they also did something. They did not transfer the technology. They did not export their technology to the country. USA did not export, and USSR did not export. They kept some privacy. They kept some secrecy. And during the same period, there was also a big race for computer technology. There was a very big race for what? For the computer technology. So computers were introduced. Okay, each and every computer has different features, different processors. So many things were happening, right? So US wanted to design a computer. They always give priority to design a computer which understands English language. Whatever you want to talk can be only in English. Okay, but Russians, they have designed their computer which is going to operate upon what? Russian language. And China has designed a computer which, and their software is going to understand what? The Chinese language. Okay, there are like these kind of things were happening around the world. For example, we India, okay, we accept whatever the technology that we are getting from USA or Russia, but always we prefer English, right? Because we can understand English. We are adapted to English. We were ruled by British for almost 400 years. We were adapted to this language. So we consider the USA technology most of the time. Likewise, many countries started using the USA technology than Russian technology, because Russian technology is very limited because of the language, because they are using Russian language. So the technology transfer and the exporting the technology was not up to the mark by Russians, but USS did this because of the English language, right? After 1989, so what happened? So there is a deadlock between between the technology transfer between this the so when USSR has collapsed and it has split into many different countries. That is a different story. But there was a deadlock between the technology, and they started to introduce a common technology which will be helpful for all the countries. Common technology in the sense, in the computer world. The computer world, they have decided to say, okay, not only English, not only Russia, not only China, we should also introduce all the languages, all the major languages that is in the world. So the computer should understand all the major languages. The computer, each and every machine should communicate with each other, no matter what languages they are using. Okay, so they have introduced a concept called they have been, I mean, it was debated, and they have introduced a concept called the Unicode concept. Unicode concept. Unicode is what? Unicode is nothing but Universal International Standard Character Encoding. What is it? Universal International Standard Character Encoding. Okay, what this has to do with the character data type? That should be the question, right? We will be understanding it shortly. Okay. Unicode is an acronym for Universal International Standard Character Encoding. Okay, which is capable of representing most of the major languages in the world. Okay, which is capable of what? Capable of, let me remove all this. Okay, which is capable of representing all the major languages in the world. Major languages. So Tamil is one among them, Telugu is one among them, Malayalam. So there are many languages. So when Unicode was introduced in Russia, they were, I mean, in USA, before introducing the Unicode, USA was following a concept called ASCII. Okay, this ASCII is a limited concept, is a limited language supporting a concept that is applicable only in the English language. It supports only the English language. It is an acronym for what? American Standard Code for Information Technology. Information technology. Okay, this ASCII is representing only English letters, English symbols, special symbols, all the English characters, and the Russians were following something like KOI, 8 for Russian language. It supports only the characters of the Russian language, and the Western European languages were there, like Spanish, you have French, you have like Portuguese, you have. They were following what their own set of languages. So they call something like ISO. I think it is 8859. Okay, this is for Western European countries. Okay, and Chinese people, they have their own standardized set of concept, which is called what? G8, thing like 185. So you do not have to remember all this. I'm just trying to introduce what is Unicode. Okay, now you will get it. Okay, GB something like 185. And that is also called a Big Five for Chinese. Okay, so these are limited to their own countries. But this Unicode as what is Unicode as a very special thing. It is going to represent all the international languages, all the major international languages. To fill this gap, because you cannot purchase a technology when you don't understand Russian. You cannot purchase a technology when you don't understand Western European countries. You cannot purchase this, but you can. Most of the people, they were able to purchase this. Not only about that, the when you want to communicate between two set of versions like Unicode or Russia or KOI8, okay, so there is a barrier here. Two computers, one from Russia and one from USA, they can't communicate with each other. So there is a big barrier. To remove that barrier, the Unicode concept has come into the picture. What I'm saying is, a ASCII cannot, you know, can be networked. You cannot make a connection. You cannot establish a connection from ASCII system to KO8 system. Both are in different languages. Networking will not happen here. So there is a barrier now. This barrier has to be removed by using the Unicode. So they have introduced the concept of Unicode. Okay. The purpose of introducing the concept is what? Now you focus here. To get over above problems, a new language protocol standard. To go to protocol standard, was designed by the name of Unicode system. By the name of Unicode system. Okay, the memory consumption is only 2 bytes. It's going to only consume the two bytes of memory in Java. It is going to consume only 2 bytes of memory. Why? Because Java uses Unicode system, and you can represent Unicode in the character data type in Java, and you can represent the Unicode system in the character data type in Java. Right? So this is all about what? This is all about the Unicode. Now the capacity, okay, again there is a range for the Unicode. The lowest capacity, the lowest range is something like the lowest value is like a backward slash, okay, and use the character U in lowercase, 4 zeros. I will tell you what is this. And the highest range, the maximum value is like backward slash and again U, okay, followed by F. Lowest range and the maximum range. Okay, when I take this as an example, okay, when I say I have a Unicode like backward slash U, 1, 2, 3, something, a random number, random number I'm taking here. Okay, this 1, 2, 4, 5 is representing an hexadecimal number. This 1, 2, 4, 5, the numbers that you see after the letter U, okay, this is representing a number called hexadecimal number. We know what is binary, we know what is decimal. Okay, and this number is representing what? It is not a decimal number, it is not a binary number, it is hexadecimal number. Decimal number. Okay. So what the Unicode as a chart, guys, in the real time, the Unicode as a chart. Unicode. There are some set of numbers, okay. The Unicode as a chart. For this particular Unicode, this is the value. For example, to understand this, let me take a small Java program. Focus here. If I want to represent what? I just want to represent the Telugu letter or Tamil letter or Hindi letter in the form of Unicode system. Okay, let me take a character. Character A equal to, right, what I want to represent? I want to represent something like a Telugu letter. Let us say Telugu letter I want to go with. If I want to go with Telugu letter, I need to find the Unicode. Let me take like Unicode like U, backward slash U, 0, B, 8, 5. Okay, system.out.println. Okay, let me print this here. Let me print this here. Okay, you are getting a Tamil letter. Okay, this is representing A. This is A in Tamil, the first letter. The first letter in Tamil is what? A. Let me do something like, let me copy this. Okay. let me do something like, okay, B, okay, and I want to do what? I want to do something like backward slash U 0 T 0, right? Okay, now I want to print both A and B, both A and B. Okay. See, you have Telugu first letter, right? So what I'm trying to say is every unique code is specifically mapped to a particular letter of a language. So this is a, let us take these two examples. Unicode, if I say Unicode, these are the few examples. Okay? So this is one of the Unicode which is representing what? This Unicode is representing, it is mapped to a particular language's letter, a Tamil language letter, Tamil, first letter of the Tamil language, which is A. Okay? This Unicode is mapped to a particular language of a, particular letter of a specific language, Telugu letter. Okay? Telugu letter. So this is representing what? This is representing A. Okay, and this is representing A. Okay, likewise, each and every Unicode is going to represent. You do not have to remember this Unicode. There is a chart for that. What I'm trying to say is, you are able to represent English alphabets or Telugu letters, Tamil letters or Telugu letters, Hindi letters, Malayalam letters, whatever it is. Okay, now if you ask me, sir, you are saying that character is a data type which is going to store a English character. Okay, at the same time, character is also a data type which can store a Unicode. At the same time, character is a data type which can also store a number. Okay, to understand that example, let me take what? Let me take character. Now do like this. Okay, let us do. Okay, now focus here. I want to take character A equal to, or character English ENG, English equal to, I want to take an alphabet A. Okay, I am doing system.out.println. I want to print ENG. Okay, if I try to execute this, the answer is very straightforward. Answer is what? Answer is A will be printed in the console. But actually, this is not the direct thing. Internally, what will happen is, okay, the compiler will perform so many actions. Okay, let us do the tracing. You are just seeing that the character is getting accessed directly by the variable name English, ENG. But it is not that, this is not the case actually. What is happening? What we have to go through? We do what? We usually do what? We just compile it, we just execute it, right? So it does so many things between the compilation and the execution. Okay, let me decrease this size to 18. Now focus here. Okay, so this is the class, right? The source file, right? a.java. Okay. To activate the compiler, what is the command? Java c space a.java. Right? So compiler will be activated, and the source file will be, the source file will be inside the compiler, right? And the compiler will generate what? The dot class file, a dot class file will be generated, right? After the a dot class file generation, you need to execute it. For the execution, the JVM is necessary, Java Virtual Machine, right? Let us say that this is JVM. Okay, for the execution, what is the command? Java space class name. The moment you give this command, okay, the a dot class file will be loaded inside the JVM. Main thread will be created, right? Now focus here. Main thread will be created. Main thread gets access to the main method. Okay, so it has found the main method. First instruction says the letter A is getting assigned to the character, to the ENG data type, ENG variable of char data type, right? So what it will do, firstly, okay, the letter A, focus here, the letter A will be converted to what? It will be converted to the Unicode. I said no. Okay. Now go back here and see. Go back and see. You are seeing the Unicodes here. So this is one Unicode and this is another Unicode, right? So this Unicode is representing, someone has joined, 1 minute. Okay, this Unicode is mapped to a particular letter, and the second Unicode is also mapped to a particular letter. So this is This is A and this is A. And likewise, A is also mapped to a particular Unicode. A is also mapped to a particular Unicode. Okay, what is Unicode for the value A? Okay, so to find that, okay, let me do something here. Okay, there is a Unicode chart. Okay, this A will be converted to the particular Unicode. I will tell you how to calculate that Unicode. Let us try to understand, what is the equivalent Unicode for the value A. Okay, it's U, this one. Okay, so we are getting this one. If you are getting plus, replace that plus with slash and the smaller lowercase. So this is the equivalent Unicode for the character A. So these things are already there in the Unicode system. Each and every letter in any language has been mapped to a particular Unicode. Okay, firstly what happens? It will take the character A. Okay, this is the actual character. Actual character. Secondly, this has to get converted to an Unicode. I mean, the Unicode is not a conversion. The mapping is already done by the Unicode system. Okay, it will consider that Unicode value. So this is the actual Unicode value. And I have just said from this Unicode value, the the last four numbers starting from right to left. Okay, this is what? This is the hexadecimal number. It will filter out the hexadecimal number. It will filter out the hexadecimal number. Understand the flow here. Okay, what is hexadecimal number that you have? 0041. 0041 is the hexadecimal number. Okay, this is the Unicode. Okay, and there you have what? Hexadecimal number. Okay, then this hexadecimal number will be converted to the what? The equivalent decimal number. Hexadecimal number will be converted to a number equivalent decimal number. Okay, let us do the conversion first. What we call this. Let us use Google for now. I will also help you with the conversion manually. Okay, convert decimal to hexadecimal number. Okay, decimal to hexadecimal number. Okay, so we want to convert from hexadecimal to decimal. Okay, so hexadecimal is 0041. Okay, 0041. Convert. You are getting a decimal number 65. Right? 65. 65 is the decimal number. Then at last, the 65 will be converted to the binary number. 65 will be converted to the binary number and will be stored in the 16-bit registry. Will be stored in how many bits registry? 16 bit. Why 16 bits? Character type is of character is the size of the character data type is what? 2 bytes. 2 bytes is the combination of what? 16 bits. Combination of two 1-byte registry, right? Two 1-byte registry. Right? 16 bits will be created, and this decimal number has to get converted to a binary number. Let me do the conversion. Can anyone help me with the answer if you have? Or else let me do it. 65 divided by 2. Balance 1. 2. 2 ones. 2 sevens. 0. 2 eights. 1. 2. 2 fours. 0. 2. 2 twos. 0. 2 1. Okay, you write the numbers from bottom to top. Okay, so 1 0 0, correct me if I am wrong, 0 1 0 1. The remaining elements will be 0 0 0 0 0 0 0 0 0 0, right? So these many things are happening. These many things are
Sir, two
happening.
32.
32 either. Is it wrong?
Two. Yes, sir. 1 5 zeros 1.
Tell me from the right to left. I mean left to right. I mean right to left. 1 3 zeros.
1 5 5
5
1.
5. Okay, okay. Okay, this is the, okay. Now see what are the things that are happening behind the scenes. Okay, you want to store the letter A to the char data type. You just want to store the letter A. To store that letter A, internally that letter A is getting converted to the Unicode. Okay, Unicode. And again, you are extracting the hexadecimal number from the Unicode 0041. Okay, this hexadecimal number is again getting converted to the equivalent decimal number. Okay, and this decimal number is getting converted to what? It is getting converted to the binary number, and it is just settled. Okay, storage has happened. You know what is the next thing that you are doing it here? Next thing, you are accessing it. You are just accessing it. While accessing it, again this binary number will be converted to what? This binary number will get converted to the hexadecimal number. Okay, this hexadecimal number will be mapped to the respective Unicode, and it is going to extract the actual character from the Unicode. Character. This is the extraction process. For the storing, these many things are happening. For one character, if you want to store, these many things are happening behind the scenes. Character is getting just remember this. Actual character is getting converted to Unicode. Okay, you do not have to remember this Unicode. I will tell you how we are getting this Unicode later. These things are already mapped by the Unicode system internally. For each and every letter, there is a specific Unicode. For A, the specific Unicode is what? Unicode is 0 /U 0041. Right, and this will be converted to hexadecimal number. This hexadecimal number will be converted to equivalent decimal number, followed by the later it will be converted to binary number. This is still storage. It has been stored successfully. Later, for the retrieval, again hexadecimal number, again Unicode, then actual character will be extracted and displayed in the console. So you just see what? You just see A in the console. To display that A, it is going through all these many operations. Okay, this is what? This is equivalent decimal number, right? Okay, now if you go back and if I go back, I can store A directly. First of all, I can place a character. I can place a letter directly. If I place a letter directly, the letter will be converted to Unicode, followed by what? From the Unicode, hexadecimal number will be extracted, followed by from the hexadecimal number, it is going to convert the hexadecimal to the decimal number system. Okay, then binary. Right, and here the reverse will happen here. Okay, the binary number will get converted to decimal. Okay, decimal will get converted to hexadecimal. This hexadecimal will find the equivalent Unicode. Okay, from the equivalent Unicode, the extraction of the actual letter will be done. Focus here, focus here. I am able to do I can possibly assign three values here. Firstly, I can directly assign a letter if I want. If I wish, I can assign a letter. Secondly, I can directly assign the Unicode if I want. If I directly assign the Unicode, what is Unicode? /U, okay, followed by what? 0041 Unicode 0041. Okay, and enclose this in single quotes, not double quotes, single quotes. If I directly assign Unicode here, okay, now the conversion will start happening from the Unicode. Okay, this letter is not there now. You are assigning that Unicode. If you assign Unicode directly, from Unicode hexadecimal number, from hexadecimal decimal number, from decimal binary number, and again for the extraction, binary to decimal, decimal to hexadecimal, hexadecimal to Unicode, Unicode to letter. This will not change. Okay, when you are assigning Unicode directly, the first, the conversion will start happening from the Unicode. Conversion will start happening from here. Likewise, you can also assign the direct number. Okay, let us see. Let us try to execute this. What we are getting, we will see. Let me execute this. You are getting same letter A. Okay? Or if you are assigning instead of this Unicode, you are assigning the direct letter, that is also possible. Okay? Character A. But if you assign character A directly, the letter will get firstly converted to the Unicode followed by the remaining steps. Instead of that, instead of assigning the letter directly, you can directly assign the Unicode also. No issues. Okay? If you're not interested in assigning Unicode directly, you can also assign what? You can also the equivalent decimal number, not binary. Equivalent decimal number. When I say equivalent decimal number, so this is the equivalent decimal number. 65. Assign that 65. If you are assigning 65, let me compile and execute this. Okay. You are getting the still here. What is happening behind the scenes? The moment you assign the number directly, this will be treated as a decimal number. Okay, these steps will be removed. From the decimal to binary conversion will happen. This is for the storage. For the execution, again from the binary to decimal number, from the decimal to hexadecimal, from hexadecimal to Unicode, from Unicode to letter. Right? So by this, I can conclude that if I want to assign values to the character data type, if I want to assign any value to the character data type, okay, I can directly assign, I can assign three kinds of values. First value is directly I can assign a letter, or if I want I can assign a Unicode, or if I want I can assign a decimal number. Okay, at the time of storing, okay, if you are assigning the letter, okay, the conversion will start happening from letter to Unicode, and it will go like this. But if you are assigning the Unicode, okay, the conversion will start from Unicode hexadecimal decimal number again. But if you are assigning the decimal number directly, the conversion will happen from decimal number to binary code. But at the time of retrieval, at the time of getting the value, at the time of accessing that value, this step will remain same. When I say these steps will be same forever while retrieving the value. But while placing the value, the steps may decrease or may increase. Able to follow, yes or no? I will ask you questions on this. That's why I'm asking. Yes, no, everyone? Unicode system.
Yes.
Able to follow? Any confusion? See, if I ask you a question, okay, you should be bold enough to give the answer. Okay. In the interview room, they will ask you, so this is the character data type. Okay, and you know that if I give something like B here, when the value B, when the character B is assigned to the character data type, you can say yes, this is valid. Okay, they would confuse you, like they will ask you, okay, what is this valid or invalid? This would be the question. What you would say directly, you are assigning a number to the character. Yes, it is completely invalid. What was our conclusion? What I said, if the number is assigned, if the number is getting assigned to the character data type, okay, go back to the conversion logic and see here. Okay, you are assigning a decimal number. In this case, the decimal number is 97. Okay, 97 is a decimal number. This 97 will get converted to the equivalent binary number for the storage purpose. After this conversion, okay, this 97 will get converted to the hexadecimal number. Okay, you are dealing with 97, guys. Directly you are placing a number 97. Okay, this will get the equivalent binary number and would get stored in the memory or would get stored in the registry. At the time of accessing this binary number, again it will get converted to what? This binary number will get converted to the decimal number, then hexadecimal number. Okay, then Unicode. Okay, then actual character. Let us do this conversion manually. 97 has to get converted to hexadecimal number. Let us do that manually. Decimal to hexadecimal. Okay, 97. Convert. I'm converting decimal number to hexadecimal. You are getting 61. Okay, go back. Okay, go back. What is hexadecimal number is 60, 61, right? 61. 61. Okay, and the equivalent Unicode for 61 is backward slash, okay, backward slash U0061. Okay, from the equivalent from the Unicode, the actual value will get extracted. What is that actual value? What is the value that we are trying to store here? Okay, 97 is the value. Okay, this Unicode for the 97, I mean, this has a special mapping. Okay, there in the Unicode system, some letter has been mapped to this number. That number will be displayed on the console. That letter will be displayed on the console. Let us see what is the letter that is getting displayed on the console. A, small a. Okay, so whatever the number you assign here, that number has what? That number has to be converted to the hexadecimal format. Then the equivalent, what we call it as the equivalent Unicode. After the Unicode, the will extract the letter, actual letter. Okay, having said this, let us see these examples. Okay, so this is the Unicode. When I'm storing an Unicode directly, at the time of storing, what it has to go through, the Unicode has to get converted to hexadecimal number, or else you can say that hexadecimal number will be extracted, then decimal number will be, it will be converted to the equivalent decimal number. Okay, not this here. I should put it here. Okay, then the equivalent decimal number will be converted to binary number. This binary number will be stored in the memory, which is what AN. At the time of execution, the reverse will happen. Binary number will be converted to hexadecimal, then decimal number, then hexadecimal number, then the Unicode. From the Unicode, actual character will be extracted. What is that actual character? If you run this, okay, so this is the actual character. Tamila. Right? The interviewer will be asking you like, what kind of data that I can store in the character data type? What types of data, what kind of data that I can store in character data type? What should be your answer? You can say, I can store the decimal number, I can store the, right, I can also store the Unicode. Okay, I can also store the actual character. So this is the special data type which can able to store three different set of values: decimal numbers, Unicode number, and the actual character. Right, making sense? By this, you will get a lot of tricky interview questions. Some tricky interview questions will be like, and if you are understanding these for loops, the loop statements. So there are some statements like loop statements in Java. We will understand. If you understand that, you will get this. Now let us try to understand this manually. So far, we have used the online application for the conversion. Right? You take any number. For example, let us take 65 as a number. 65 is what? 65 is a decimal number. Decimal number. If you want to convert this to binary, first let us, if you want to convert this to hexadecimal number, let us understand the values of hexadecimal number first. Okay, so let us say that this side is representing the decimal number and this side is representing hexadecimal number. Okay. In hexadecimal, okay, if you have a decimal number like 0, okay, the hexadecimal number is also 0. And for 1, hexadecimal is also 1. For 2, hexadecimal is also 2. For 3, hexadecimal is also 3. For 4, hexadecimal is also 4. For 5, 5. Okay. 6, 6. 7, 7. 8, 8. 9, 9. Okay. If you take a decimal number like 10, and in hexadecimal number, it is A. Equivalent hexadecimal number for the 10 is A. You take 11, the equivalent decimal number is, the equivalent hexadecimal number is B. Okay. Likewise, you take 12, C. You take 13, D. You take 14, E. You take 15, F. Okay, the hexadecimal number ends here. Okay. The hexadecimal number will represent numbers from 1 to 9, followed by the letters A, B, C, D, E, F. Now remember this logic. Okay, I have 65. Now also remember the base value of decimal number is, if you want to talk about the base, 10 is the base value for the decimal number. For the hexadecimal number, the base value is 16. We have discussed about decimal number in the beginning of the primitive data types. If base 10 is the base value, but for hexadecimal it is 16. If you want to convert a decimal number to the hexadecimal number, keep dividing the decimal number by 16. Keep dividing the decimal number by what? 16. Okay, 16 fours what? 60, 16 fours are 16 fours, 64. Right? 16 fours, 64, right? Balance is going to be what? Balance is going to be 1. Right? Write the number from bottom to top. Okay, 41 is the hexadecimal number for the decimal number 65. Likewise, if you take a number like